Okay, so you've learned all these nice linear algebra concepts, and now it's time to look at some applications. Balancing chemical equations. How many recall doing that in chemistry? Sure, Mikhail remembers it, Cameron, and how many remember you have to kind of, you know, figure out, it's like little puzzles, right? Well, we can actually use linear algebra to help us. Well, okay, Mikhail, and this is a reaction, right? So let me give you a moment to copy the problem down, and then I will we'll talk about it. So Jonathan, you recall doing it, but you don't remember. Well, linear algebra is going to be a nice way to balance chemical reactions. So let's see here. Now, what are we actually doing here? What are we actually doing? On the left, uh, well, so yeah, so all we're saying here is that we are taking, do you remember what C3, C is what kind of atom? The C atom is carbon. Good, that's right, Jonathan. H is hydrogen, right? O is oxygen. Good. Okay, so that's right, Mikhail. So C3H8, you know what that is? That's propane. So if you combine propane and oxygen in the right amounts, it's going to produce what's CO2? Carbon dioxide. That's right, Jacob. That's right, Cameron. Carbon dioxide, okay. And H2O is what? You should know that. That's water, right. So the question is, I want to say this the right way. We want to balance the equation. So we have to find, well, I want to say it the right way. We need to figure out what amounts of these reactants are needed and what it's going to produce. Okay, what amounts are going to be produced. So what we can do is for every one of these molecules, okay, and there are 4 molecules here, right? We can represent each molecule with a vector. We can represent each molecule with a vector. Okay, so for instance, let me show you how to do this. In our solution. So we need to find, to balance the equation, we need to find coefficients x1, x2, x3, and x4, x1, x2, x3, and x4, such that we have a balanced chemical equation. And it used to be, I remember in high school, what we had to do is, count up the atoms on each side until, and then you work it out until you get the balance. But it can be difficult to do, depending on the type of reaction you're working with. So let's denote the number of atoms per molecules using vectors. Right, and so and Mikhail knows, Mikhail sounds like it's had a lot of chemistry. And this might be a reaction that's easier to balance than others, but certainly let's use our knowledge of linear algebra to help us here. So the propane molecule C3H8 has 3 carbon atoms, 8 hydrogen atoms, and no oxygen atoms. Okay, so the vector that represents the propane is 380. Oxygen, okay, for there's no carbon atoms, no hydrogen atoms, but there are 2 oxygen atoms. You see, so the first entry is the number of carbon atoms, the second entry is the number of hydrogen atoms, and the third entry is the number of oxygen atoms. CO2 can be represented by the vector 102, and H2O can be represented by the vector 021. Okay, so this chemical reaction here, can be represented as a vector equation as this vector equation. So to balance the equation so all the material gets used, we have to solve this vector equation. Please let me know if you have any questions. Yes, this here is an equal sign. That's correct. That's correct. This is an equal sign. Yes. So we end up with this vector equation, and vector equations, of course, can be they represent a hold on here. I always want to have my saying right. They represent a system, in this case, of linear equations. So what we want to do is, well, let me see here. I'm going to go to the whiteboard. I'm going to put in another step here, but are there any questions before I go to the whiteboard? Okay. I want to show you this. So, okay, so we have x1 times the vector 3, 8, 0 plus x2 times the vector 0, 0, 2. And what I'm going to do is I'm going to bring over the other 2 vectors from the right side and put them on the left side. So that'll give me minus x3 times 1, 0, 2, and then minus x4 times 0, 2, 1. And what's that going to equal then on the right side? What's that going to equal? Right, Bellin, the 0 vector. So we want to express this vector equation as a linear system of equations and then generate an augmented matrix. So we want all the variable terms on the left side. Okay, so we would have then 3x1 plus 0x2 minus 1x3 minus 0x4 equals 0. That's the first equation. And then we'd have 8x1 plus 0x2 minus 0x3 minus 2x4 equals 0. Okay, and then we'd have, for the third equation, 0x1 plus 2x2 minus 2x3 minus 1x4 equals 0. Is this system of equations non-homogeneous or non-homogeneous or homogeneous? Homogeneous, that's right, Mikhail. That's right, Jonathan, because we have zeros on all zeros on the right-hand side of those equations. So now what we want to do is take this system of linear equations and express it as an augmented matrix. Are there any questions before I go, back to the, this is really part of the solution, but I'm going to go back to the document here. Okay. Well, then let us go back to the document. So here we are. And now, here is our augmented matrix. Will there be a free variable? We have 3 equations with 4 variables. More variables than equations. So that's right. That's right, Mikhail. There is going to be a free variable in our solution. Now, what happens in section 1.6 is some of the problems. This problem is something you could probably do. You could do the row operations by hand. But for some of the problems in section 1.6, the row operations you have fairly sizable matrices. Okay, you're going to have problems, for instance, dealing with general flow patterns of networks. There's an example of that in your example 2 in section 1.6, and as well as just different applications, and the augmented matrices are fairly large, so we're going to use MATLAB to help us. So this is the first time I think you're being introduced to MATLAB. But we can put this matrix in MATLAB, this augmented matrix, and MATLAB will give us this matrix here, this augmented matrix here. And is this augmented matrix in echelon form or reduced echelon form? Reduced echelon form, that's right. That's right. So very good, everybody. So let me, I have MATLAB here. Let me just, okay. So let me bring it up. Are there any questions so far? We want MATLAB to give us this answer here. So what we have to do is we have to type in our original matrix. Mikhail, for MATLAB, I will certainly in the class try to show you how to use MATLAB, but you will have to do some learning on your own. It's not hard if you go to Google and type, like how to row reduce a matrix in MATLAB. things will pop up, all kinds of things, and sometimes they're manuals and everything. Well, MATLAB can do some wonderful things, Jacob. You'll see. It's more than like Desmos. I can tell you that. You'll see that. You'll see that. But Desmos is great. But MATLAB stands for Matrix Laboratory. It's designed to work with matrices and very large matrices. It's it's excellent software. How many of you used MATLAB in another class, by the way? Maybe an engineering class or another math class. All right, Belen has, Yasin, Marcella, David. Yes, it is. And there's a reason our courses for them to transfer. A lot of institutions want MATLAB. And remember, you get it free. You get it in the under course orientation. There's instructions how to install MATLAB for free. Okay. Okay. So let me bring up the MATLAB here. Let me just bring it up. Okay. So here's MATLAB. Okay. Is MATLAB showing okay in the screen? Maybe give me a thumbs up if you're seeing it all right. Okay, very good, Yasin. Very good, Cameron. Wonderful. Thank you, Marcella and Mikhail. So what I'm going to do, this is the command window. This is the command window. And I'm going to just, by the way, if you ever need help on something, if you click on the little FX thing there for function, that's your help. And you can type in, like, if you wanted to know about, like, I don't know, eigenvalues. Okay, well, hold on, I didn't spell it right. That's something we'll see later. But eigenvalues, you see there's all kinds of examples of how to do eigenvalues in MATLAB. That's a great way to get help. Now, we want to type in our augmented matrix. I have to give it a name, so I'm just going to call it matrix A, even though, it's an augmented matrix. So I'm typing in the numbers for the first row, and then I use a semicolon to separate out the first row from the second row. And then here's another row. You can use commas between the numbers. It's optional. Okay. So let's see now. Let's see if I typed it in. Okay, let me hit enter. And we have, I think it looks good here. Okay, okay. Now, I'm going to use a command called format RAT. What that's going to do is it's going to, when the row reduction's done, it's going to give me fractions, okay, in the reduced echelon form of the matrix. I want to use fractions because, MyMathLab wants like fractional answers, right, unless told otherwise. The command to do reduced echelon form is RREF. RREF. Okay, so you do that on matrix A, hit enter, and there it is. There it is. And that's the matrix. That's the reduced form of the augmented matrix. Format RA2, what that does is it creates fractions. It creates fractions in the row reduction. If you had, like, I'll show you something here. If you had format num, I didn't do it right. Format num. Hold on, one moment. Probably have that wrong. One moment, let me check it. Hold on. I'm going into Google. and looking at formats in MATLAB. Hold on here. Sorry, just give me a moment here. Give me a moment. Yeah, so like let's say, let me see here. Let me do CLC, that clears the screen. If I did format long, for instance, format long, I don't know if you've heard of that. And then I use my arrow key. I can use my arrow key to get back like previous commands that I did. And I do RRF of A. See that? Gives me long, lots of decimals. Lots of decimals. Okay? How many have heard of format long? You can have format short, format long. And this is important. This will be important for some problems in the future that you'll need to do. You'll want a lot of accuracy on those, on your decimals. But in this case, because these problems are, chemistry problems are, they usually work out with nice numbers, right? Ultimately we want integers. So we need nice numbers. So I'm going to go back to format RAT and then bring it back again. There we go. Are there any questions so far before I go back to the document for our solution? Was this helpful seeing this? I was debating about showing it, but was it helpful? Okay, wonderful, wonderful. Excellent, excellent. All right, good to hear. And it is being recorded, so it will be in the recording. Okay, so we go back to the document here. Okay, now, so MATLAB, you can use it for section 1.6. Okay, but for this exam, obviously, I want to see that you understand row operations, and conceptually, it's important to do them so that you just have a feel for matrices. But for section 1.6, you may use MATLAB to help you with those problems for sure. Okay, so now let's go ahead and get our solution. This is our solution. So the x4 is a free variable. Actually, if we go back here, let me just clear this. Clearly, maybe I can just do a little something here on this page. One moment. So clearly x4 is free, and x3 is 3/4 x4, and x2 is 5/4 x4, and x1 here is 1/4 x4. Okay, so, all right, I like to do it right there where the matrix is. So here are our answers. And now what we have to do is we have to figure out, well, x4 is a free variable. But since we're doing it with the chemistry application, we need to have integers for our coefficients. We can't let x4 equal like 2.5. Okay, we have the coefficients, the x1, x2, x3, and x4 have to be integers because atoms per molecule is an integer. So, let x4 equal 4. If you do that, then you have x1 is 1, x2 is 5, x3 is 3. Very simple. And so in this case then, here is your, I'll put a 1 here. Whoops, hold on. One moment. Yeah, I'll put a 1 there. So there's the 1, there's the 5, you know, x1 is 1, x2 is 5, x3 is 3, and x4 is 4. So for your home, for like your exam, I am going to want to see the work though that you have here. I don't want to see just an answer. You have to for like a chemical problem, chemistry problem, you have to write down the vectors for each molecule, provide the vector equation, get the augmented matrix, and then use MATLAB. You can use MATLAB then to get the reduced echelon form of the augmented matrix. You know, I mean, I am going to need to see this justifying work. Okay. I have to see that you know how to use linear algebra for the chemistry problems. And by the way, you want to use, I mean, there are other numbers too that can be used here. Like for instance, if this, since this is the case, you could have a 2 here, a 10 here, a 6 here, and an 8 here, right? I mean, would those numbers also balance the equation? They would, but my math lab will not accept those answers. It'll count them as wrong. It wants answers in like the lowest form. 2, 10, 6, and 8 are all divisible by 2. So you have to get the answers like in the lowest, like so that the coefficients can't be like all they can't be divisible by any number. You know, all divisible by well you know what I mean. They have to be in reduced numbers as far as possible. And I believe that's standard in chemistry, right? When you do that, the simplest form. Okay, very good, very good. So somebody said, how many would have liked to have had this in maybe in their chemistry class, this knowledge of using vectors? Okay, Mikhail would have liked that, sure, sure. Okay, so that's a chemistry application. I'd like to look now at another application here. Are there any questions before we move on? Okay, well, let's move on then. Okay, an economic application, economy. Let me give you a moment to copy this example down. Okay, this example actually goes with, well, you have an example 1 in your textbook that has an economy with 3 sectors in it, but we're going to do one with 2 sectors. So let me let you copy this example down. Okay, so let's look at this problem. We have an economy here, an economy that has two sectors, goods and services. Now, goods sells 80% of its output, what it produces, to services and keeps the rest, while services sells 70% of its output to goods and retains the rest. Okay, so goods sells its output to services. Okay, so services like plumbers, electricians, mechanics, they all need in their business, they make use of goods, right? When they repair things, they have parts, things like that. So goods sells 80% of its output to services. And services sells 70% of its output to goods. So services, goods, you need equipment you need services to make the goods, you see. So this is just a very simple kind of economy, okay? But you can see there's an interaction between goods and services. Now, what we want to do is we want to find what are called equilibrium prices for the annual outputs of goods and services sectors that make each sector's income match its expenditures. Okay, so basically we're talking here about a balanced economy where the income match the sector's income match their expenditures. Okay, so just a very simple kind of situation here. I'm trying to see if there's anything else here that I can. Okay, all right. So what we have to do is we have to set up a system of equations. Okay, but first we have to make use of the information given to us in the problem. And what we can do is make a nice little table. We can make a nice little table. So let me show you how we would do that. So here, what are equilibrium prices? They are prices such that the income of each sector exactly balances its expenses. Okay. So there's what's called a distribution table for this particular economy. You have an economy that involves services and goods. Now the outcome, the output of services and goods are both at 100%, right? It has to be, right? So if we look at the first row here, services purchases 80% of goods, but and I'm going to say services purchases 80%. I'm sorry, I want to say this the right way. Hold on. Let me go back to the actual problem. Yes, services. All right, goods sells 80% of itself to services. Okay. And services sells 70% of its output to goods, but keeps 30%. So services keeps 30% of itself. Okay, so it's using services for services. So it retains services retains 30% of its output, but purchases 80% of goods output. On the other hand, goods purchases 70% of services output, but retains 20% of itself. So that's the distribution table, the output distribution table. And based on that table, we can create a system of equations. And this is the system below. We want to find equilibrium prices, and we'll call the prices, it makes sense we would use P for price. Price of services, P sub S, and price of goods, P sub G. Well, based on the distribution table here, we come up with these two equations. Services is purchasing 30% of itself and 80% of goods. So the cost of services is paying 30% of its. I want to say this the right way. Of the service expense. So services is paying 30% of buying 30% of the service expense and 80% of the goods expense. Well, that's going to have to equal the income, the total income of the services. Meanwhile, the income of goods has to equal what it's paying out. It's paying out, it's buying 70% of the price of services and 20% of the price of goods. So the income of goods has to equal 0.70 times PS plus 0.20 times P sub G. Are these equations okay that we have below here? I mean, are there any questions on either of those equations? Mikhail, you're comfortable with them? Please let me know if you have any questions. The augmented matrix is actually, well, let me ask you this. In these equations here, in these two equations, okay, how many variables are there? How many variables are there? 2. So the augmented matrix would have how many coefficient columns? Would have 2. Well, that's right, Yasin. Belen, you're right. The augmented matrix altogether will have 3 columns, and 2 of those columns are for the coefficients. So what we're going to do is we're going to do exactly like we did for the last problem. Let me go to the whiteboard here. PS and PG do not combine together, Mikhail. They do not. Good question. Let me show you that. Let me go to the whiteboard. Hold on. One moment. Let me clear this. So let's write down what we have here. Okay, so we have 0.30 times the price of services, right? Plus, hold that thought, 0.80 times the price of goods equals the income of services. So, and we have 0.70 times the price of services plus 0.20 times the price of goods equals the income of goods, P sub G. So what we can do here, we can combine, we can subtract. Sorry, that should be a little smaller there. I'm making, hold on here. Right, and if I do that, I'm going to get -0, or we will get -0.70 PS plus 0.80 P sub G equals 0. And similarly, for the other equation, okay, that's a 1 there, I can subtract 1 P sub G from both sides. Okay, and let me just sort of, that cancels. That's the whole reason we're doing this. Mikhail, and let me do a little separator here, a little separator. Yeah, we want to combine like terms. We want to combine like terms if we can. Okay, so what we're doing is creating a homogeneous system, a homogeneous system in economics here. And now these are the two equations we're going to work with. This one and that one. Are there any questions? So, Mikhail, you're okay, you're comfortable? Okay, no problem, no problem. Okay, let's go back to the, if we're good with this, let's go back to the document. So this is where we were, and now we are here. And I just showed you how we got to here. And now it's time to write out the augmented matrix and do row reduction. This, I don't think we need MATLAB for this one, right? What I'm doing is, well, what am I doing here? I'm taking, let's see, I'd rather have integers and decimals. So I'm taking -100 times row 1, putting the result in row 1. No, that's, I didn't do that up there though, hold on. Yeah, I took -100 times row 1 and put the result in row 1. And then I took -100 times row 2, from here, and put that result in row 2. Hold on. You're right, it's not 100, it's 10. Yep, thank you, Mikhail, thank you. I think there was another person who corrected me there. You're right, yep. -10 times row 1. Thank you. Result in row 1. And then -10 times row 2. Replace the second row with that new row. And that gives us this. And now if I just add row 1 to row 2 and replace row 2 with that result, that'll give me this here. and it's in reduced echelon form. I'm going to have one free variable. PG is free. Okay, and then I solve for P sub S. Price of goods is a free variable. Price of services is equal to 8/7 times PG. So that means if the price of goods were $7 million, the price of services would have to be $8,000. Okay. Are there any economic majors in here? I know we have some computer science majors, but do we have any econ majors? Minors, maybe? Okay, all right, Jacob. Well, Jacob's thinking about it, maybe. Who knows? Okay, okay, that's fine. Okay, let me, one moment here. I want to bring up the ebook just for a moment. I know there's some chatting going on, but one moment, let me get that ebook up here. Okay, one moment here. Hold on. Okay, if we're good here, let me bring up the ebook. Okay, all right, Jonathan's econ and computer science major. Okay, okay. Yeah, if economics, you can make a little bit of money in there. Yep. Another application. This is a engineering application that you'll see, and I'm going to let you look at this second example. It has to do with network flow, and there's a lot of applications for network flow. Okay. They mention here that systems of equations arise naturally when we study the flow of some quantity through a network. For instance, urban planners and traffic engineers model the patterns of traffic flow in a grid of city streets. Okay, electrical engineers can calculate current flow through electrical currents. And economists, well, and then we just saw the economical application. So what they have here in example 2 here, hold on here, they have in this example, I knew that would happen, I knew it. Hold on here. Let me get back here. One moment. Yeah. They have an example where the network in figure 2 shows the traffic flow in vehicles per hour over several one-way streets in downtown Baltimore and during a typical early afternoon. Determine the general flow pattern for the network. So they have, you know, how would we read the numbers on this little diagram here? Okay, so like if you look at intersection A, you have flow in and flow out. So intersection A is the intersection of what streets for intersection A in the picture? Intersection A, what two streets are at the intersection? In example 2. That's right. Pratt Street. That's right, Mikhail, and Calvert Street. And what's coming into Pratt Street? Well, okay, you have 300 cars coming into Pratt Street. Well, this is vehicles per hour. 300 vehicles per hour reach intersection A through Pratt Street, and 500 vehicles per hour reach intersection A through Calvert Street. And we want the flow in to equal the flow out. Okay. We want the flow in. Well, the flow in should equal the flow out. So 300 plus 500 would equal x1 plus x2. You see, and you can provide for all these 4 intersections equations. Okay, and what you want to do is you want to solve for x1, x2, x3, x4, and x5 in this case. Okay, that's what you want to do. I'm just trying to see if there's any. So you're basically trying to determine these flow rates. And let me just see here. Yeah, so I think this example, if you read through it, I want to give you a little time here because we need to move into section 1.7. But if you work through this example, and you would use MATLAB to help you with this, if you work through the example, you have your system of equations here, system of linear equations, and then you work it out. You work it out. So I think that example you're going to be fine with that. I'm not too concerned. But let's see. Belen says the arrows doesn't mean anything. The arrows are just the direction of the traffic flow. In the picture, the arrows. Yeah, that's what so like on Pratt Street, Pratt Street is a one-way street, and traffic is it moving to the right or the left on Pratt Street? Well, look at the arrows. The arrows determine the direction of the traffic. Is traffic moving to the right or to the left on Pratt Street? To the right. That's right, Bella. Now on Lombard Street, is the traffic moving to the left or to the right? On Lombard Street. To the left. So yeah, so hopefully, I think this example will be, I think you'll be fine with it, but you'll have to, look at it. But at least I've talked about it a little bit with you. All right, I'm gonna stop there. Are there any questions? Okay, good. All right, I'll stop. Very good.